All right, we are slowly coming to a close to the end of our series here, guys, and I'm sure a lot of you are probably wondering, like, what is going on, or maybe a little overwhelmed, and we'll hopefully put it all together now in geometry and everything like that. You guys have studied sine, cosine, tangent, SOHCAHTOA. Now, believe it or not, the unit circle is the foundation of where SOHCAHTOA comes from. Now, we've already come to the agreement that the radius is 1, right? The radius is 1. That's why at all these corners it's 1. It's just that we have an x and y axis over here. Let me go ahead and fix that up right there. And this is a radius of 1. Okay, this is our x axis. This is our y axis. Now, if we were to use SOHCAHTOA on this, right, we get sine of our angle being this individual right here, is equal to opposite over hypotenuse. Well, opposite is the y divided by our hypotenuse. Well, the hypotenuse is 1 because that's our radius. The radius of a unit circle is 1. So we get that the sine of an angle is equal to y. Now, if I do SOHCAH, the CA part, we get cosine of an angle is adjacent over hypotenuse. Well, the adjacent side is x, and the hypotenuse is 1. So we get cosine of this angle is equal. And I'll tell you what that means in a moment. Last but not least, we get tangent of this angle. This angle is opposite over hypotenuse. Sorry, opposite over adjacent. So we get y over x. Well, what is y? Well, y is sine. So we get tangent of theta is equal to sine over, and x is cosine, so we get cosine of theta. So we get that tangent of theta is equal to sine of theta, which is basically means the angle over cosine of this angle right there. What does that mean? Well, that means if you know the angle, and if I do, let's say sine of 45 degrees, sine is the y coordinate. Sine is our y coordinate here. So basically, if I have a 45-degree angle, which we've already covered, when I plug this into my calculator, this will actually give me the y coordinate here. Or I could do sine of pi over 4. Now, if you watch the previous videos, 45 degrees is the same as pi over 4. We should get the exact same thing. Pi over 4, 45 degrees, we'll get the y value. So watch if I go on Google, and sine of 45, we get 45. Let's change it to degrees. Sine of 45 degrees. Okay, here we go. Sine of 45 degrees is 0.707, and if we do cosine, we get 0.707, right? We're getting 0.707. 0.707. We get the same thing. Well, remember when we did the 45-degree angles, what did we get sine of 45 to be? Well, essentially, this is just the square root of 2 divided by 2. 0.707, right? And we talked about it using right triangle geometry. This is the square root of 2 over 2. Square root of 2 over 2. They're the exact same thing because a 45-degree angle, remember the side lengths are the same. So it makes sense that we're getting 0.707, which is just a decimal form of square root of 2 over 2. So we can use these. Oh, shoot, this should be, we could change this to cosine, by the way. Cosine of pi over 4. Here we go. And we'll still get 0.707 or cosine of 45 degrees. We're still going to get it no matter what, right? They mean the exact same thing. We're going to get both of these values here. And so that's kind of a big takeaway here, guys, is that sine and cosine actually come from the unit circle. So every time you were plug in sine of 30 degrees, you'd get that value. Now, again, if we just kind of quickly make a circle, oh my God, that's right there. What is going to be our coordinate points? Well, sine of 30 degrees is our y coordinate. Remember, the y coordinate was 1/2 when we did this earlier, and we should get 1/2. So watch if I go over here and type in sine of 30 degrees, I get 0.5, 1/2. I can type in sine of pi over 6. Remember, that is the pi measurements, and we're going to get the exact same thing, 0.5. So you can see here, sine represents our y coordinate, and if I do cosine of 30 degrees, I will get the square root of 3 over 2, which is what will go right here. This is the coordinate for this point right here. Now, it's going to give it to me in a decimal form, which is why in math we prefer fractional over decimal form. But I can type in cosine of 30, and I will get square root of 3 over 2, or roughly 0.8, whatever it was, 0.806. I couldn't remember exactly. So that's the big takeaway here, guys, is sine is the y coordinate and cosine is the x coordinate of our unit circle. And we could theoretically, any angle we want, 180 degrees, for example, at 180 degrees, we know this coordinate point is -1, 0. We can plug these in and get these values. For example, if I do cosine of 180 degrees or pi, remember that this is pi, I'll get -1. So if I come out here and do cosine, I get -1 because cosine is your x coordinate. And if I do sine of 180 degrees or sine of pi, I'll actually get 0. I'll get the y coordinate. And I guess just for the kicks and giggles, why not just do that? Boom, so we get 0. So that's how the unit circle, guys, relates to everything we've learned. It's basically the foundation for where sine and cosine come from, and a big part of how we'll utilize that. And in AP Calc, we're going to get things like you're going to need to find what is sine of pi over 3 and things like that, which we can kind of talk about later and how to problem solve. So with that being said, guys, I'll go ahead and conclude this video. It's just going to show you now where sine and cosine come into play with this. Hopefully that made sense, guys. I'm out. Take care.